Welcome to the Kennecott Glacier. This is the 2020 field study of an NSF-funded project with Regina Hawk as the PI. I'm Eric Petersen. I'm a postdoc who's leading this whole effort. And this is one of my favorite spots here. This is a super glacial stream valley, which is incising in and creating all of these ice cliffs. There's a beautiful meander right here. Wow! The Kennecott Glacier is debris covered. We're actually standing on it right now. If you look at what my feet are standing on, we've got rocks and gravel and dirt. But if you dig deep enough, in most cases only 10-20 centimeters, there's ice underneath this. You can see some ice right here. This is an ice cliff. This is where the glacier surface is steep enough that the rocks can't stick to it and they slough off. We're interested in ice cliffs because debris-covered glaciers don't melt as fast as clean glaciers. The rocks help to blanket them from hot summer temperatures and prevent the sun from beating directly on the ice surface and melting it. But that effect is offset when you have all of these ice cliffs exposing ice and enhancing melt. And we're trying to understand what causes the ice cliffs to form, how they evolve, how they persist through time, and how we can incorporate them into our models of glacier melt. And one of the ideas that we have is that they're controlled by the incision of melt streams into the ice. I'm standing here by a moderately sized melt stream flowing this direction and meandering about. And you can see that it has a particular relationship with this ice cliff right here. So the melt stream has undercut this cliff. You can see this right here, this overhang of ice. The stream at one point was up higher and has cut deeper into the ice and meandered off to the side. And we're starting to look at remote sensing data of these ice cliffs and see that the morphology of the ice cliffs looks similar to the morphology of meandering rivers on Earth. And this is very interesting to me in part because you get meanders on streams and glacier ice, but it's because of the melt. But it produces the same kind of shape that you see in meandering rivers on Earth, which are produced by the deposition of sediment here and there. It's time to harvest the fruits of our labors. Or perhaps I should say, the roots of our labors. We got a good crop this year. So these are tidbit temperature sensors with data loggers built into them. They're just a couple centimeters across, and you can bury them in the soil, or in this case, on the debris cover of the debris-covered Kennecott Glacier. You can measure the temperature in the debris and use that to calculate the amount of heat energy that's being transmitted through the debris that's available for glacier ice melt. And all of this is very important to understand because debris-covered glaciers, they're very common in Alaska, in the Himalayas, in high mountain Asia, and in the European Alps. In fact, a huge proportion of the world's population in India and a huge proportion of the food that we grow is watered by fresh water that comes from the melt of debris-covered glaciers. So we need to understand how they melt a little bit better in order to plan for the future.